Okay, so on the last slide, we ended with just discussing how whenever we have the probability of at least one, means one or more. So the best thing to do from that is that think about it of at least one, it's 100% minus the only thing that we don't want is just the probability of having nothing. So at least one is 100% everything we want except for the one that's the probability of none. So anytime you see that the probability of at least one, always just use 1 minus the probability of none. It just usually makes the questions a lot easier. So if you have any questions on that, just let me know. All right, so let's just take a look at another question. On a recent day, the Arizona Star forecast a 50% chance of rain in Oro Valley and a 50% chance of rain in Marana. What is the probability it will rain in both cases? Hopefully you recognize the fact that the two cities are independent of each other, since when you're in one city, the weather in one city doesn't change or affect the weather in another city. Therefore, since they're independent, we can use the multiplication rule if they're independent and just multiply the two probabilities together to get 0.25. So just make sure for your homework that you show your work. So don't just write probability of rain in both is 0.25. Make sure you show that 0.5 times that 0.5. All right, so I'm going to read this and I want you guys to try it and then take a minute and look at the answer once you're done just to see how you did. So many employers require prospective employees to take a drug test. A positive result on this test indicates that the prospective employee uses illegal drugs. However, not all people who test positive actually use drugs. Suppose that 4% of prospective employees use drugs. The false positive rate is 5% and the false negative rate is 10%. Okay, so false positive means it's a positive, but they didn't take drugs. False negative is saying that they didn't take drugs when in fact they did. So we want to know what percent of prospective employees will test positive. Now, you want to think about which way you want to start this question. Do you want to use a Venn diagram? Do you want to use a tree diagram? Do you want to use a table? Can you use the independent probability or the independent multiplication rule? So think about this for a second before you take a look at the next slide. Okay, so hopefully you recognize the fact that this says, suppose that 4% of prospective employees use drugs. Basically 4% of the prospective employees use drugs. The false positive is 5%. So this right here is a conditional probability. The false positive is 5%. So when this is saying of prospective employees, so we have two conditions here. We have the condition that we have a prospective employee and the fact that we have a false positive rate and a false negative rate. Both of those false positive and false negatives are based on whether or not they use drugs. So once you understand that that's a conditional probability, hopefully you'll recognize that you want to use a tree diagram to do this. All right, so think about with your tree diagram, the difficult part is thinking about what you do first. Well, what has to happen first? First, they have to take the drugs or not take the drugs. Then they're going to get drug tested. All right, so let's take a look at this, what we were given in the problem. Number one, we said that 4% of people took drugs. So therefore, since these two branches have to add up to 100%, we know that 96% of the people don't take drugs. Okay, then the next thing we know we can get a false positive 5% of the time. So what does a false positive mean? A false positive means that if you didn't take drugs, so it's the condition that you didn't take drugs, that you are still going to get a positive. Therefore, that means if you didn't take drugs, you're going to get a negative 95% of the time, since these two have to add up to 100%. We also know we are going to get a false negative 10% of the time. That means they did take drugs, so think about that condition. That means they did take drugs, but it came out to be a false negative 10% of the time. When they did do drugs and it came out positive, that's 90% of the time. Those two have to add up to 100. Now notice that I multiplied across all of the branches. You always want to do that because it makes the answer a lot easier. So what's the probability that you test positive? Because they can test positive if they took drugs or they didn't take drugs. So I want to add those two together to get 0.084. Okay, so take a look at the next question. This was a little bit trickier, but this is really helpful having that tree diagram available to you. So what percent of prospective employees will test positive actually use illegal drugs? So sort of mull that over for a second and think about what kind of question that is. Okay, hopefully you recognize that this is a conditional probability question. What percent of prospective employees who test positive actually use illegal drugs? The hardest part here is deciding what is the given. What are you given first? You're given that they test positive. So we know that they've tested positive. That's what we're given. How many of those who actually tested positive did use illegal drugs? So the first thing to do is to recognize that conditional probability. And just understand that it doesn't use the word given. You have to think about it. Now, remember I said on a couple previous slides, who, whose, that's sort of another word for given that you can sort of recognize here. So writing this portion is extremely important. What's the probability that they took drugs given that they were positive? So remember your numerators, drugs and positive, the intersection over what's given, positive. Now, drugs and positive, boom, that's super easy to get because I already did that in my tree diagram. But positive, remember, isn't just a 1. For the denominator, you can either look back at part A or you have to understand that there are 2 places that they can test positive that you have to add together for that denominator. Show this work right here. Okay, and then your 0.429. So 42.9% of prospective employees who test positive actually took drugs. Okay, let's go ahead and try one more with some Venn diagrams. So in a sampling student opinion, it's found that 40% of the students surveyed favor the resumption of the military draft for young men, 35% favor a draft for young women for service in some capacity, not necessarily military, and 55% favor neither. What I want you to do is take a minute and draw a Venn diagram showing these probabilities. Okay, so let's see how you did. So this is a little bit tricky. All right, number 1, this part right here wasn't too bad. We knew that 55% favored neither. Okay, so that was outside of the Venn diagram. So we have our men, okay, the resumption of a military for men and for women. All right, so number 1, start with the 55% that favor neither because that's on the outside. That's not too difficult to find. Now, here's what we know. Since the probability, because we don't have this and section, and this and section is always what you want to fill in first because the whole women has to add up to 35%, the whole men has to add up to 40%, but we weren't given the intersection of those who believe that both men and women should be drafted. But here's what we do know. We do know that the complement of men and women being drafted is 55%. Therefore, if everything inside of my Venn diagram has to add up to 100%, I know that within these 2, it has to be 45%. So basically, no men or women being drafted is 55%. Men or women being drafted is the 45%. So you can have men or women plus none. That gives me my 100%. Okay, so now I know that this whole thing right here has to add up to 45%. So I can use my formula for non-mutually exclusive events where I add the probability of men plus the probability of women minus the intersection, which is what I don't know here, to figure out exactly what that intersection is. Okay, so we're going to use that addition rule for non-mutually exclusive events. So we know that men or women is 45%. We know that the probability they favor women is 35%. The probability they favor men is 40% minus the intersection because we aren't sure what that is. So we're just going to solve and say x is equal to 30. And then once you have this 30% here, you know that this whole women's circle has to add up to 30% or 35%. So you just do 35% minus the intersection gives me 0.05. This whole men has to add up to 40%. So 40% minus the 30%, that's the intersection, gives me my 0.1. Add those up, you get your 0.5 probability. Okay, so this actually makes it a little bit easier to answer the following questions. So what's the probability that a randomly selected student will favor a draft of young women if it is known that he or she favors a draft for young men? So we're given the fact that they favor the draft for young men. So what's the probability that they will favor the draft of women given that they favor the draft for men? Well, we know from our Venn diagram and from the previous question that favoring for men was 40%. The intersection from our Venn diagram, 30%, show this fraction, get your final answer. What's the probability that they'll favor a military draft of young men if it's known that the student opposes any kind of draft? All right, so we know that they're opposing any kind of draft of young women. All right, that's what you have given. Okay, what's the probability that they'll favor a draft for men given that they haven't favored any for women? Now, if we're looking at our Venn diagram to find if they don't favor any for women whatsoever, you want to add up everything outside of the women category. So this 0.3 and this 0.05, that's all in your women category. What's outside of it? The 0.55 and the 0.1. So that's where your denominator 0.65 comes from. The numerator is what's the probability that they do both, men and don't favor women. So you're looking for that and probability. What's the probability that they favor men but don't favor women? So look back at your Venn diagram. Favor men is that 0.1, but don't favor women. So I just have the men portion, no women portion. My 0.1 goes in the numerator here. Show that fraction, get your final answer. What's the probability that your student will oppose a service draft for young women if it's known that the student favors a draft for young men? So once again, what's given? They are favoring a draft for young men, opposing the draft for young women. So just keep in mind that WC is the complement. There is the opposite of what's given. So they're opposing, that's everything outside of women. They're opposing the women, but we know that they favor men. So on your Venn diagram, once again, okay, your given statement goes on the bottom. We know that the probability that they favor a draft for young men is 40%. What's the probability that they don't favor women and they do favor men? Okay, outside of the women, okay, so completely outside of the women and do favor the men is the 0.1. Okay, so anything outside of the women, so you show that fraction and then your final answer. Here's your Venn diagram. Okay, so probability can be a little bit tricky, so every problem you try is different. The best way to get better is practice. There are a bunch of practice problem sets, so please just make sure you try them before turning in your homework or taking the unit exam. All right, good luck.